Far beyond the orbit of Neptune, in the deep frozen twilight of our solar system, something is pushing things around. In that vast, dark frontier, a collection of small, icy worlds are moving in ways they shouldn't. Their orbits are strange, tilted, and impossibly aligned, as if they are being marshaled by the gravity of a massive, unseen hand. For over a decade, astronomers have been gathering clues, following the gravitational breadcrumbs left by these distant objects. They point towards a staggering conclusion. There may be a huge unknown world hiding in the darkness, a true ninth planet waiting to be discovered. This is the story of the hunt for what is hiding at the very edge of our solar system. To understand the mystery, you must first travel to its location, the Kuiper Belt. It is a colossal debris field, a ghostly ring of trillions of icy bodies that encircles our solar system, beginning just past the orbit of Neptune. These are the leftovers from the formation of the planets, the primordial building blocks that never quite managed to coalesce into something larger. For decades, we knew it only as the home of Pluto, but as our telescopes grew more powerful, we began to uncover a whole menagerie of other small, frozen worlds out there, dwarf planets with names like Eris, Makemake, and Haumea. Then, in 2003, we found something truly bizarre, an object named Sedna. Sedna's orbit was unlike anything we had ever seen before. It was immensely elongated, swinging so far out from the sun that it takes over 11,000 years to complete a single circuit. More strangely, its closest approach to the sun is still incredibly far away, completely detached from the gravitational influence of Neptune. Something long ago must have kicked Sedna into this wild, lonely orbit. It was the first major clue that the tidy, well-understood model of our solar system was missing a piece. For years, Sedna was an anomaly. But then we started finding more objects like it. A handful of these extreme trans-Neptunian objects, or ETNOs, were discovered, all with bizarrely stretched out orbits that kept them far from the gravitational grasp of the known planets. And as astronomers plotted these new orbits, a startling pattern began to emerge. It was a pattern that would launch one of the greatest astronomical detective stories of the 21st century. The story of Planet 9 truly began with two astronomers at Caltech, Mike Brown and Konstantin Batygin. Brown was famous for his role in the demotion of Pluto, having discovered Eris, another Kuiper Belt object more massive than Pluto, which forced a revaluation of the definition of a planet. Initially, Brown and Batygin were skeptics. They believed that the strange orbits of these few icy worlds were the result of an observational bias. Astronomers tend to point their telescopes at specific parts of the sky at specific times of the year. So they argued it only looked like the objects were clustered. They set out to build a mathematical model to prove that the clustering was just an illusion. They fed the data into their simulations, fully expecting the model to show that the orbits were random. But the opposite happened. The math stared back at them with an undeniable and shocking pattern. The elongated orbits of these half-dozen ETNOs all pointed in the same general direction in space, like a set of compass needles all mysteriously aligned. Furthermore, their orbits were all tilted in the same way, leaning out of the flat plane where the 8 known planets travel. Batygin calculated the odds of this alignment happening purely by chance. The probability was just 0.007%. It was so statistically improbable that it was virtually impossible. It was not an illusion. Something real, something massive, had to be responsible for gravitationally shepherding these tiny worlds into their impossibly aligned paths. After trying and failing to make any other explanation work, they were forced to consider the one they had set out to disprove. The math didn't just allow for a new planet, it demanded it. In 2016, they published their bombshell paper, laying out the evidence for what they called Planet 9. The hypothesis was as elegant as it was stunning. Hiding in the outer darkness, they proposed, is a massive planet, a world unlike any other in our solar system. It is thought to be between 5 and 10 times the mass of the Earth, making it a super-Earth, or a mini-Neptune. This isn't a small, icy dwarf like Pluto. It would be the 5th largest planet in our solar system. Its orbit is predicted to be vast and elliptical, similar to the ETNOs it controls. At its closest, it might be a few hundred times farther from the Sun than Earth, but at its farthest, it could swing out to more than 1,000 times that distance. A single year on Planet 9 would last between 10,000 and 20,000 Earth years. its gravity acting like a colossal, slow-moving shepherd over billions of years. Perfectly explains the strange clustering of the distant Kuiper Belt objects. It corrals them, organizes them, and keeps them locked in their peculiar aligned orbits. The hypothesis was a beautiful solution to a nagging cosmic mystery. But it immediately raised a new question. If it's out there, why can't we see it? The answer is distance. An object that far away would be incredibly punishingly faint. It reflects almost no light from our distant sun, making it colder than liquid nitrogen and dimmer than a candle on the moon. Adding to the difficulty, it moves incredibly slowly. Astronomers find planets by detecting their motion relative to the fixed background stars. But Planet 9 creeps across the sky at such a glacial pace that distinguishing its movement from the background noise is a monumental challenge. Nevertheless, the hunt is on. Astronomers across the globe are using our most powerful telescopes like the Subaru telescope in Hawaii to scan the predicted path of Planet 9, hoping to catch the faint pinprick of light that would change our map of the solar system forever. The best hope may lie with the new Vera C. Rubin Observatory in Chile, which will survey the entire southern sky every few nights with unprecedented depth. Planet 9 is out there. The Rubin Observatory is expected to find it. Of course, the hypothesis is not without its critics. Some scientists argue that the clustering could be an illusion after all, that it could be explained by the collective gravity of thousands of smaller objects in the Kuiper Belt, requiring no single large planet. But as more and more of these strangely aligned objects are found, the evidence for a single massive perturber grows stronger. Whether it is a planet or something else we don't yet understand, the clues are undeniable. The outer solar system is not the static, lonely place we once imagined. It is a dynamic system being actively shaped by a gravitational ghost. The quest to find Planet 9 is more than just a search for a new world. It's a journey to the edge of our knowledge, a detective story written in the slow, silent language of gravity. The darkness is hiding a secret, and we are, at long last, beginning to see it.